Now, like last time, we have seen first the few questions, and then we saw the explanation part of each one of them. So today also we will see some 10 to 15 questions. So the first question is: phenylalanine, the precursor of most of the phenolics in the higher plants, is the product of which of the following pathways? Shikimic acid, malonic acid pathway, or mevalonic acid or methyl erythritol pathway. Next question is: which of the reagent can be used to protect the ketone group? Acidic methanol, basic methanol, methanol plus KCN, or dietherbutyl dicarbonate. Question 26. Which of the following drugs causes less inhibition of REM sleep? Zolpidem, ethanol, lorazepam, or phenobarbital. Question 27. The starting material for the synthesis of sulfamethoxazole are? You have four options. Question number 28. The clinical trial registry in India is maintained by World Health Organization Delhi, or ICMR New Delhi, or Institute of Clinical Research New Delhi, or Central Drug Standard Control Organization New Delhi. Then question number 29 is: match the natural product with the chemical nature. So you have pronacine, silibinine, hypericine, senosides, and you have to tell what is the chemical nature of them. Then the question is: which is the correct order for the unsaturation present the following fatty acid? Palmitoleic, linoleic, linolenic, and arachidonic acid. So you have to find out what is the order for what is more unsaturated than the others. Then which of the following is not a component of evaporator? Heat exchange, vacuum separator, condenser, or cyclone separator. Question 32. In Parkinson's disease, there is a predominant loss of dopaminergic neuron primarily in whether it is substantia nigra, cerebral cortex, or locus coeruleus. Then question 33. At equilibrium, the receptor occupancy is related to drug concentration by which of these equations? Anderson-Hasselbalch, Hill-Langmuir equation, Lineweaver-Buck equation, or Langmuir adsorption isotherm. Question number 34. Which method is not suitable to calculate the area under curve? Least square method, trapezoid rule, weighing and platometry, or integration of curve. Question 35. The clinical trial is being conducted in 1,500 volunteers, in which that spans on the period of 2 years as per protocol. The clinical trial is in which phase? 1, 2, 3, or 4? Then which of the following is not undergone a clinical trial for its use to decrease the intracranial pressure? Dideoxyinosine, zidovudine, acetazolamide, or nicotine. Question 37. Colloidal dispersion have which type of rheology? Newtonian, pseudoplastic, or non-Newtonian, or dilatant? Which of the nitrogen atom in the imidazole is more basic? Nitrogen A or nitrogen B? Both N are equally basic, cannot be said. What is the product of the given reaction? Then match the antimalarial drug with the mode of action. You have artemisinin, pyrimethamine, quinine, atovaquone, or proguanil. The next question is the mathematical equation. Ethanolic solution contaminated with benzene showed the absorbance of 0.69 at 260 nanometers in the 2 centimeter cell. If the molar absorptivity is 230 per mole per centimeter, what is the concentration of benzene in the solution? And the last question: which of the following is example of diazonium ion? CH3N2, CH3N3, CH3N2, or NH2NH3, or none of these? Now, shikimic acid pathway is a metabolic 7-step pathway in the bacterial, fungi, plants for the synthesis of aromatic amino acids like phenylalanine, tyrosine, tryptophan. Now, this shikimic acid is completely absent in animals, and hence all the above amino acids are essential to animals. The other one, mevalonic pathway, is for production of isoprenoids. Okay, so next question is: what is the reagent Which of the reagents from the given can be used to protect the ketone group? We have acidic methanol, basic methanol, or methanol plus KCN, or ditertiary butyl dicarbonate. Now, when we have a molecule which undergoes a reaction having more than one functional group, there is a possibility that the other groups may interfere. So to ensure that the reaction takes place in a only at that required functional group, protection of the other group is to be done. Now this is a temporary chemical transformation of reactive group into the group that does not react under the conditions where the non-protected group reacts. Now here in the question it is asked ketone is to be protected. Okay, so now aldehyde and ketone, they react with the alcohol, that is in presence of acid catalyst, to give the geminal diproduct. We call them as acetal or ketal. Now this dimethyl acetals, you can see the reaction R-C double bond O R dash giving R dash and O methyl. Now this is a ketal. Okay, now this you can see on the arrow, it is methyl alcohol H plus, that is in presence of acid as a catalyst, and the other product is water. So now the dimethyl acetal can be prepared from carbonyl compounds with excess methanol catalyzed by protic acid or Lewis acid together with the dehydrating agent. So this will drive the equilibrium to the right of the reaction. So then we go to the next question. The next question says, which of the following drugs cause less inhibition of REM sleep? The answer, the options are zolpidem, ethanol, lorazepam, or phenobarbital. Okay, now the normal sleep consists of two major states: non-rapid eye movement sleep (NREM) and the other one is rapid eye movement sleep, that is REM. Now this NREM makes 75% of the total sleep, while REM, that is rapid eye movement sleep, occurs cyclically over the interval of 90 to 100 minutes. Now the conventional sedative hypnotics, they reduce the time to fall asleep, reduce the REM. So conventional sedative hypnotics reduce REM, reduce time to fall asleep, whereas and the tolerance develops say in a week. Withdrawal can result in the rebound, increase REM. Now zolpidem and zaleplone suppress the REM to a lesser extent than the benzodiazepines, and therefore they may be superior to the benzodiazepines as hypnotics, while zopiclone inhibits stage 1 and stage 2 of NREM. So we go to the next question. The starting material for the synthesis of sulfamethoxazole are, the options are given. Now we need to know what is sulfamethoxazole. Now sulfamethoxazole is a molecule. Sulfamethoxazole is the first molecule shown in the reaction. These are the sulfonamides which are used for several bacterial infections, and the basic compound from this category is sulfanilamide. From sulfanilamide several compounds were synthesized and tried. So here we have the sulfamethoxazole. This molecule, if it is broken, you can see what are the two possibilities, what are the two products. So these are the starting material for the synthesis of sulfamethoxazole. So first one is, we have 4-amino benzene, 1 sulfonyl chloride. The first product you can see it is a 4-amino benzene, 1 sulfonyl chloride. And what is the other product? This is isoxazole ring. Now what is isoxazole? This is a 5-membered ring containing nitrogen and oxygen at position 1 and 2. So the other molecule is 3-amino 5-methyl isoxazole. Okay, so this is so the starting materials for sulfamethoxazole synthesis, we have 4 first one is 4-aminobenzene, 1 sulfonyl chloride, and the other one is 3-amino 5-methyl isoxazole. Now the next question is about clinical trial registry. The question is, the clinical trial registry in India is maintained by, options are World Health Organization Delhi, or ICMR Delhi, or Institute of Clinical Research New Delhi, or Central Drugs Standard Control Organization New Delhi. Now for conducting the clinical trials in India, we have the prerequisites that permission from the DCI, Drugs Controller of India, is to be taken, then approval of the respective ethics committee when study is planned, and mandatory registration with the clinical trial registry on the ICMR maintained website. So these are the question. Number 29 is, match the natural product with the chemical natures. We have pronazine, silibinine, hyperazine, and senosides. So we can say pronazine is glucoside of D-mendylenite. Silibinine is naphthodienthrone. Hyperazine is flavonolignan, and senoside is the anthraxine carboxylic acid. The correct order for unsaturation present in the following fatty acids: palmitoleic, linoleic, and arachidonic acid. Now see, we can the nomenclature is given, so let us see first what is arachidonic acid. Arachidonic acid is all cis 5,8,11,14 eicose tetranoic acid. Then you have alpha and gamma linolenic acid. So alpha linolenic is all cis 9,12,15 octa DK trinoic acid, and gamma linolenic is all cis 6,9,12 octa decatrinoic acid, whereas linoleic is all cis 9,12 octa decadinoic acid, and palmitoleic is cis 9 hexadecanoic acid. So obviously the correct order will be arachidonic having more unsaturation than linolenic, than linoleic, and finally palmitoleic acid. Question number 31 is, which of the following is not a component of evaporator? Heat exchange, vacuum evaporator, condenser, or the cyclone separator. So all these first three, heat exchange, vacuum separator, condenser, they are the component of evaporator, while cyclone separator is the instrument which is used for particle separation based on the rotational movement and gravity. Now question number 32 is, in Parkinson's disease there is a predominant loss of dopaminergic neuron in, the options are substantia nigra, cerebellar cortex, cerebral cortex, or locus ceruleus. Now here we know that substantia nigra is rich in the dopaminergic neurons, while the other one, locus ceruleus, is rich in noradrenergic neurons. Now the next question is about equilibrium. At equilibrium, the receptor occupancy is related to drug concentration by which equation? Henderson-Hasselbalch, Hill-Langmuir equation, or Langmuir adsorption isotherm, or Lineweaver-Burke equation. At equilibrium, the receptor occupancy is related to the drug concentration by which of these equations? Now the Hill-Langmuir equation is a ligand receptor interaction kinetics. This is a variation of the Langmuir adsorption isotherm generated by applying law of mass action to the binding of ligand to its receptors. Now the fraction of the receptor occupied is given by this equation: concentration of the ligand upon concentration of ligand plus the dissociation constant, that is Kd. Now the other equation, that is Lineweaver-Burke equation, is a reciprocal of Michaelis-Menten. We have discussed in third or fourth question of the 2016 question paper, that was about Michaelis-Menten equation for enzyme kinetics. So that is a reciprocal of that equation is Lineweaver-Buck equation. So we have 1 upon V is equal to Km plus substrate concentration divided by Vmax into substrate concentration. Question 34 is, which method is not suitable to calculate the area under curve? We have the options least square method, trapezoid rule, or integration of curve, or weighing and platometry. The least square method or the line of best fit gives the best fit of set of data in the graphical form and its equation. Trapezoid rule gives AUC, that is AUC is equal to, in the trapezoid rule, area of all the trapezoid that can be drawn beneath the curve with the smallest width possible. Smaller the width, the more accurate is the estimation of overall area. Planimeter or platometer is the instrument used to measure area under curve. Again, weighing is an old physical method for determining area under curve. For example, the plot will plot the curve, cut out the area under the curve precisely, and measure the sensitive and accurate weighing balance. The AUC will be proportional to the weight of the paper. The question is, the clinical trial is being conducted with 1,500 volunteers, which may span on the period of 2 years as per the protocol. So the clinical trial is in which phase? Phase 1, phase 2, phase 3, or phase 4. You are having 1,500 volunteers and the period is 2 years. So which is the phase? Now we can see in this table, phase 0 is a trial phase with number of subjects at 10 to 15, and the purpose to determine the pharmacokinetics and pharmacodynamics. Phase 1, we take 20 to 100 healthy volunteers or the people with the disease or the condition, and that will take several months to determine the safety and the dosage. Phase 2, we take up to several hundred volunteers with a disease condition, and it takes from several months to 2 years, that is to find out efficacy and side effects. Phase 3, now here you have 300 to 3,000 volunteers who have the disease or the condition, and that may take 1 to 4 years. To find the efficacy and monitoring of the adverse reactions. Phase 4 requires several thousand volunteers who have the disease or the condition. The length of study is continuous to find the efficacy and safety. Now the next question is, which of the following drug has not undergone a clinical trial for its use to decrease the intracranial pressure? The options are dideoxyinosine, zidovudine, acetazolamide, or nicotine. Which of the drug has not undergone a clinical trial for its use to decrease the intracranial pressure? Now the FDC of US government was amended in 1962, and by this the companies are required to provide evidence of safety and efficacy of the drug for its approval. Now synthesis of, out of the 4 options given, acetazolamide was reported in 1950. It was assessed in 1958 to decrease the intracranial pressure and on its property to inhibit the enzyme carbonic anhydrase. Now it was accepted as a treatment for the patient with high intracranial pressure, but there has never been a randomized clinical trial to prove that it is effective. The next question is, colloidal dispersion have which type of rheology? So we know colloidal dispersion show thixotrophic rheology, that is a type of non-Newtonian flow. The question is, which basicity of which nitrogen is more, Na or Nb? Now as you can see, the lone pair of electron from Na is involved in resonance, while lone pair of electron from Nb is not. So the basicity of nitrogen will be Nb greater than Na. Now in the Diels-Zeller reaction, this is a type of pericyclic reaction between the conjugated diene and alkene or alkyne. So that will give you cycloalkene or cycloalkyl diene respectively. Now here you have ethylene, this is unreactive. And which are the good dienophiles? You can see here you have good dienophiles are conjugated aldehydes, ketones, esters, and nitriles. Now ethylene react with diene in the harsh condition, and all the others react with a mild heat or light conditions. Now this is dienes S-cis conformation. You can see here this is double bond at this position, or if it is a 5-membered ring. So this is all this is diene S-cis conformation. Dienes react more with the electron releasing group. Now the diene must adopt a S-cis conformation to be reactive. Now here you can see this is the dienes trans conformation. This is S trans. Okay, this is unreactive. This will be reactive if by equilibrium this becomes like this. Now in this reaction the cyclic product is formed by a concerted process where the electron rich carbon of the diene forms a bond with the electron poor carbon of the dienophile. Okay, now here you can see this is our cis conformation. Now this is your double bond. So now how this product is formed? You have this double bond will come here, this will come here, and this bond will come here. So now what is the product? You get the double bonds at this position and this position. Now what is the stereochemistry of the reactant and the product? Okay, now if you have a cis dienophile, now this is reacting with, say this is your cis dienophile, so the product will be cis. Okay, if this is a trans dienophile, as you can see this is a trans dienophile, so this is CO methyl, CO methyl. So what should be the product? The product will retain this trans conformation. It's converted to which compound in presence of CrO3 with acetic anhydride? Now toluene in this condition will be converted into benzaldehyde. Okay, the for oxidation CrO3 based reagents we have many, like Fischer reagent, Cornforth reagent, Jones reagent, Killiani, or Serethor-Thiel reagent. Now if you use KMnO4, toluene is converted into benzoic acid, and if you are taking CrO3 with acetic anhydride, then toluene is converted to benzaldehyde. Number 41 is match the anti-malarial drugs with the mode of action. We have the drugs like quinine, pyrimethamine, artemisinin, and atavacone or proguanil. Now what is the mechanism of action of artemisinin? Artemisinin causes generation of oxygen and carbon-centered radicals. Pyrimethamine, it causes inhibition of dihydrofolate reductase. Then quinine, we know this is causing inhibition of the heme polymerase, and the atavacone or proguanil, it inhibits the parasite mitochondrial electron transport system. Is question number 42. It is ethanolic solution contaminated with benzene showed absorbance of 0.69 at 260 nanometers in a 2 centimeter cell. So if the molar absorptivity of the benzene is 230 per mole per centimeter, what is the concentration of benzene in the solution? Now we know the equation A is equal to epsilon BC, or if you want to find a concentration, this is equal to A divided by epsilon into B. Now absorbance is 0.69, this is divided by the molar absorptivity. What is epsilon? This is a molar absorptivity, which is 230, and the cell B is a path length, that is 2 centimeter. So if we do the calculation, 0.69 divided by 230 into 2, so that comes out to be 0.0015 molar. So the concentration of benzene in the solution will be 0.0015 molar. Question number 43 is, which of the following is example of diazonium ion? Now options are given. So we have CH3N3 is nothing but methylazide anion, CH3N2 is methyl diazonium ion, and NH2NH2 is your hydrazinium ion. So now the answer is, which of the following is example of diazonium ion? So you can say that CH3N2 is the diazonium ion.